In this video, we're going to look at how to solve systems of equations by graphing. When we're solving a system of equations by graphing, the first thing we're going to do is start by graphing both equations. So we're working with linear equations here. And so we're going to start by graphing the first equation. So what we're going to graph first is our y-intercept, which is right here, -4. So on the y-axis, we're going to make a point at -4. From there, we're going to use our slope to find more points on the line. So remember that this x really has a 1 in front of it. So our slope is 1, which we can write as 1 over 1. So this means we're going to go up 1 and to the right 1. So from our y-intercept, we go up 1 and to the right 1, and we make another point. And I can continue to do that to make more points on the line so that my line is as accurate as possible. So I'm going to make a few more points by continuing to go up 1 and to the right 1 from each point. And then once I have quite a few points, I'm going to connect those to make my line. Then I'll go back and I will graph the second equation. So starting with the y-intercept, which is at +5. So on the y-axis, I'm going to go up 5 and make a point. That is my y-intercept. And then my slope is -2. So remember, I can write that as -2 over 1, which means I'm going to go down 1 into the, down 2 into the right 1. So I'll go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And I've actually found the intersection while doing that, but now I can go ahead and connect those points. And so remember, the solution to a system is the point that both lines share, which is right here. And we write this as an x comma y ordered pair. So the x coordinate there is 3, and the y coordinate is -1. So to get to that point from the origin, we would go to the right 3 and down 1. So I want to make sure to check this. It has to work in both equations. So I'm going to replace, in the first equation here, I'm going to replace y with -1, and I'm going to replace x with 3. So I want to know, is -1 equal to 3 minus 4? And it is. So it works in the first equation. Then I'm going to test it out in the second equation. So I'm going to plug it into this one. Again, I'm going to replace y with -1. And I'm going to replace x with 3. So is -1 equal to -6 plus 5? And it is. So it also works in this equation. So since it works in both equations, I know that my answer is correct. All right, let's look at our next system. So these aren't in slope-intercept form, our y equals mx plus b form. That makes graphing equations really easy. So what I'm going to do is I'm going to solve each of these equations for y. So I'm going to start by moving this 3x over to the other side. So that gives me -y equals -3x minus 3. And then remember, I want to solve for positive y, so to get rid of that negative, I'll just divide every single thing by -1, and that gives me y is equal to 3x plus 3. So that is my first equation. Again, I'm going to start by graphing my y-intercept, which is 3. And then from there, I'm going to take my slope, which is 3, but I can write it as 3 over 1. That tells me to go up 3 into the right 1 from my y-intercept to make my next point. And I can do that 1, 2, 3 to the right 1 again. Now, I would like some points over on the other side, so what I can do instead is reverse both of those directions. I can go down 3 into the left 1 to get more points. So starting at my y-intercept, if I go down 1, 2, 3 into the left 1, there's another point on my line. I can do that again and again, down 3 into the left 1, and you can see all of those points lie on the same line, so I know they're correct and I can go ahead and connect those. So let's go ahead and solve our next equation for y. This one's pretty simple. All I have to do is move the 2x over by subtracting it. So y is equal to negative 2x minus 7. So I'm going to start by graphing my y-intercept, which is negative 7, on the y-axis, and then my slope is negative 2, which I can write as negative 2 over 1, which means to go down 2 into the right 1. So from my y-intercept, I'm going to go down 2 into the right 1. Now again, I'm running out of room and I'd like some points on the other side. So if I want more points in the other direction, I can reverse both of those directions, up 2 and to the left 1. So from my y-intercept, I'm going to go up 2 into the left 1, up 2 into the left 1, up 2 into the left 1. So I have more points on my line. Here is my other line, and you can see again, we found the solution, which is this ordered pair right here. And we write that as, again, an x comma y. And so if we look for the coordinates of that ordered pair, we would have to go, to get to that point, we'd have to go to the left 2, so negative 2, and down 3, so negative 3, and then we're going to go ahead again and check that in both equations. So plugging it into the first equation here, I'm going to replace x with negative 2, and I'm going to replace y with negative 3. And I want to know, does that equal negative 3? So this gives me negative 6. This becomes a plus 3. Is that equal to negative 3? And it is, so I know it works in this equation. And then I'll plug it into the bottom equation. So again, I'm replacing x with negative 2. I'm replacing y with negative 3. And I want to know, does that equal negative 7? So that gives me negative 4 plus negative 3. Does that equal negative 7? And it does. So since it makes both equations true, I know that it's the correct solution. Okay, here's our next example. We're going to start by graphing the top line. So we have a y-intercept of 3 here. And then our slope this time is 2, which remember is the same as 2 over 1, which tells us to go up 2 and to the right 1. So from my y-intercept, I will go up 2 into the right 1. And then if I want some points in the other direction, remember I can go down 2 into the left 1. And so here's quite a few points on my line, so I know my line is going to be very accurate. And there's my first line. Now my second equation is not in slope-intercept form, so I'm going to start by solving for y, which means I'm going to move the 2x over. So negative y is equal to negative 2x plus 7. And then again, I want to solve for positive y, so I'm going to go through and divide everything by a negative 1. So that gives me y equals 2x minus 7. So my y-intercept is at negative 7, so right here. And then again, I have a slope of 2, or 2 over 1, which tells me to go up 2 into the right 1. So I'll make a few points on the line. And what you can see is that these lines are parallel. And we knew they were going to be parallel because they both had exactly the same slope, which means they're increasing at exactly the same rate. So because they're parallel lines, they're never going to intersect. So this system has no solution. There is no point that those two lines are ever going to share because they're never going to cross. All right, in this next example, it might look like our first equation isn't in slope-intercept form, but it is. We can just flip those two and write this as y equals 2x if we want. Now remember, if there's no number being added or subtracted, it means there's really a 0 there. So that is our y-intercept at 0. And then from there we have a slope of 2. Again, 2 over 1, which tells us to go up 2 into the right 1. So from my y-intercept, I'll go up 2 into the right 1, and I'll just keep making points on the line. Again, I can go down 2 and left 1. And then here is my first equation. Now, the second one is not solved for y. It's not in slope-intercept form, so let's go ahead and do that. We'll move the 2x over. So we get y equals 2x, or y equals 2x plus 0, which is exactly the same thing we had before. So if I go to graph the second line, it's going to lie right on top of the first line. So like we talked about before, if that happens, it means every single point on both of these lines intersect. So every single point is a solution to the equation. And there's so many solutions that we can't possibly write them all. So we say that this has infinitely many solutions. Another way that we sometimes write this is that we say x, comma, and then when we solved for y here, we got y equals 2x, so this would be 2x here. Okay, our last two equations are slightly different because I wanted to remind you about horizontal and vertical lines. So you'll notice that this first equation only has a y variable. So the first thing I'm going to do is I'm going to solve for y by moving that 1 over, and I get y is equal to 3 if I subtract 1 from both sides. So what this means, if it just has a y, is that it's only going to go through the y-axis right here. So if it's only going to cross the y-axis, it means that it has to be a horizontal line. It has to go left to right. So I'm going to go to where y is 3 right here, and I'm going to make a horizontal line through that point. So this is the line for y is equal to 3. Now the next equation only has x in it. So I'm going to start by solving for x by dividing both sides by 3, so I get x is equal to 2. So that means it's only going to cross the x-axis. So if that happens, if it only crosses the x-axis, that means it has to be a vertical line. It has to go up and down. So I'm going to go to where x is 2, and I'm going to make a vertical line through where x is 2. And you can see that because we have one horizontal and one vertical, our lines do intersect. Again, our intersection is our solution as an x, y ordered pair. So this ordered pair has coordinates 2, 3, which you'll notice were the equations of our horizontal and vertical lines. So we can check this in both equations. I'll start by checking here. So because I only have a y, I'm only going to plug in y. So does 3 plus 1 equal 4? And it does, so it works in that equation. And then I'll plug it in the second equation, which you'll remember only has an x, so I'm only going to plug in the 2. The x coordinate is 3 times 2 equal to 6, and it is, so it works in both equations, which means this is the correct answer.